We'll be looking at molarity. Molarity is represented by a big M, and its units are moles per liter. Molarity is equal to the amount of moles of your solute over the liter or volume of your solution. Now, you can use this as an equation and just divide to get your molarity. But what if you're given unknown moles or unknown liters? You can solve for it. So moles is going to be equal to molarity times liter. Now you could represent this as moles per liter to see that your units would cancel out and you'd be left with just plain moles. Now liter, if you cross multiply and then solve for liter, so it would be M times L equals moles, divide by molarity. So it's going to be moles over molarity, represented by mole per liter. Now, the easiest thing to do is calculate molarity with your two givens. So let's say that for IV fluids, it has a 0.90 gram of NaCl per 1 liter. The only problem is that our given is in grams, meaning that we're going to have to change this to moles by using our molar mass. So we're going to go 0.09 grams of NaCl over 1 times the amount of grams in NaCl per 1 mole. So to calculate the molar mass of NaCl, you'll know that Na is approximately 23 and Cl is approximately 35. So we're going to do 58 grams of NaCl. You'll divide 0.90 divided by 58 to get the number of moles here per 1 liter. Now that we've calculated that we have 0.015, notice how I went to 2 sig figs because our given had 2 sig figs. Now this problem wasn't too bad because our volume was just per 1 liter. So the molarity of this IV bag would be 0.015 molar solution. Now you could represent it by big M, or you could keep it as moles per liter. Your book will show you that for molarity you'll have it as molar or capital M. Now let's try this problem to find out how many moles there are. There are 2 different ways you can figure it out. You can remember that we had moles is equal to the molarity times the liter. The other way we can do it is that I'm going to show you in 2 tables, is use dimensional analysis and use this molarity as a conversion factor. How many moles are there in a 2 liter? So I'm going to write our knowns up here. In a 2 liter solution that has a molarity of 2.5 molar. Now the first way is that we can just use this equation like so. So moles is going to be equal to our molarity times liter. Our molarity in this problem is 2.5 times our 2 liters. So we'll find out that we have 5 moles of whatever we're looking for. Now, the alternative is to use dimensional analysis. So you are given that you have a 2 liter solution over 1. Now, we're going to look at our molarity as a conversion factor. So we can break up 2.5 molar into 2.5 moles per 1 liter. Do we have to change this conversion factor? No, because what we want to cancel out is already on the bottom as 2.5 mole. Now, it seems simple enough to go through this process at either way. It becomes a little bit more complicated if you're given your units for your moles into grams, because then you could just add on to the dimensional analysis and go that one extra step to grams of what you know. Let's try this example. Calculate the number of moles and grams for a 1 liter solution of 0.50 molar of NaCl. So I'm going to use the dimensional analysis route, knowing that I'm going to eventually get to grams. So what I'm starting out with is that I have a volume of 1 liter, which makes it easier on us. Now let's make this into a conversion factor. It will be 0.50 moles per 1 liter. Let's start to set it up. We have our given as 1 liter over 1. Now we might want to write how many sig figs this is so we can know how many we need at the end. So we're going to write 2 sig figs to remind ourselves that we're going to need sig figs. Per 1 liter, we got this number from our molarity, and we'll have 0.50 moles times. Now, am I done right here to do the first part of the question? Yes, so I just want to multiply 1 times 0.5. So I could stop here and say that I have 0.50 moles of my NaCl. But we're going to go that extra step now to grams. So we're going to use molar mass. Remember, we're going to look at the one before, and it's going to be 1 mole is equal to 58 grams of NaCl. We're where we need to be to solve for grams. So we're going to multiply across. Now you could have just done 0.5 times 58. So when you multiply 0.5 times 50, 29 grams of NaCl for the solution.